This conference will now be recorded.
6.01, describe the properties of the atmosphere. And this will be a 30-minute lesson. So the importance of this, the importance and objectives of this. So first of all, the objectives is you guys will know the different properties and the factors that affect the properties of the atmosphere. And it is important for the cadets to understand this to enhance your knowledge on the weather and how it is created and what processes go on for different weather phenomena to occur. So teaching point 1 is the composition of the atmosphere. So the atmosphere is composed mostly of a mixture of invisible gases. It is mostly nitrogen, which makes up about 78% of the atmosphere, and oxygen, which makes up 21%. There's another 1% that is made up of other gases like carbon dioxide and argon. The atmosphere also has a lot of different things in it. It has all kinds of different particles like dust particles and pollution. But most importantly, it contains water vapor. And water vapor is very important. It is found in the lower levels of the atmosphere and is the most important part because it is what creates weather, clouds, and yeah. So confirmation of teaching point 1. What percentage of the atmosphere is made up of nitrogen? Yep, 78%. That's right. Yeah, let me know if you can hear me okay. I can speak up or yeah. Okay, and the next question is what percentage is oxygen? Yeah, it's 21%. And what part of the atmosphere is the most important? What water vapor? Yep, that is correct. And can anyone say why? Yes, yeah, it creates weather in the clouds. Okay, that's good. And we'll move on to the next teaching point, which is teaching point 2, and it is divisions of the atmosphere. So we'll be talking about the different levels. So the atmosphere is divided into 4 distinct layers. There's the troposphere, which is the lowest around the Earth. Around the equators, it is a lot larger, and I'll explain that in the next slide. Then there's the stratosphere, which is above that. Then there's the mesosphere, thermosphere, and then the thermosphere. And the exosphere is just space. So first we have the troposphere, which is the lowest layer. It starts at ground level and extends to various heights above sea level. And around the equator, it extends higher than at the poles because there's more terrestrial radiation that is pushing the air upwards. So there's more heat, and when there's heat, that causes the hot air to rise. The pressure, density, and the temperature will drop with height. So as you go up in the troposphere, the pressure density and temperature will drop, and the temperature will go to a low of around -56 degrees Celsius. Most of the weather occurs in the troposphere because of the amount of water vapor and the strong updrafts that occur within. And the top of the troposphere is known as the tropopause. So the very top layer, it acts as the boundary between troposphere and the stratosphere. So next we have the stratosphere. It extends around 50,000 feet upwards from the tropopause, and in the stratosphere, the pressure continues to decrease, but the temperature will gradually increase to around 0 degrees Celsius. The bulk of the ozone layer exists in the stratosphere. This prevents the more harmful of the sun's radiation from getting to the surface. This is why the temperature starts to increase again, because it's blocking the sun's radiation. And once again, at the top of this layer, the stratosphere, it's called the stratopause. It is, again, the boundary between the stratosphere and the mesosphere. So next we have the mesosphere. In the mesosphere, you can find temperatures as low as -100 degrees Celsius at around 275,000 feet above sea level. In the mesosphere, meteorites usually start to burn up if they come close to Earth. And again, at the top, it is called the mesopause. So in this layer, the temperature continues to decrease. Same thing with the pressure. And the last layer before space is the thermosphere. It is the highest of the 4 layers, and it is named the thermosphere because of the extreme temperatures that you can find in here. Depending on solar activity, so if it's directly in the sunlight, you can expect temperatures of 15,000 degrees Celsius. And it can be a lot cooler if it's in the shadow. There isn't much up here. It's just very low pressure and very low and high temperatures. So now we'll do conformation. So can everyone name one layer of the atmosphere? So just everyone name one. Then there's 4 of them. Yep, the stratosphere, thermosphere, just 2 more. Yeah, then one of them starts with an M, if that helps. And that's right. And the last one is the lowest and starts with a T. It's not exactly what I'm looking for, but that is. So the first one was the troposphere, which is the lowest of all four of them. So there's a troposphere, stratosphere, mesosphere, and thermosphere. In which layer does most of the weather occur? Yes, that's right, the troposphere. And can anyone explain why? What causes the weather? Why would it occur in the troposphere? Yep, it's the lowest, but it occurs because, yes, all the water vapor and the strong updrafts. That's right. So last one is, in which layer is the ozone layer found? Okay. It's found in the stratosphere. Oh yeah, that's right. Okay. So teaching point 3 is the ICAO standard atmosphere. So the International Civil Aviation Organization standard atmosphere. This organization makes the standards for it sets the international standards for the purposes of aviation. So they decide uh, what um, what the mean sea level pressure is, what the sea level temperature is, and what the lapse rate, which is many how much the temperature drops when you go up in height. So for North America, uh, you assume that air is a perfectly dry gas with no water. Um, the average sea level pressure is 29.92 inches of mercury, which is what you would set your altimeter to. And that the mean sea level temperature is 15 degrees Celsius, and the lapse rate is 1.98 degrees Celsius per 1,000 feet. So you would assume that you lose 1.98 degrees every 1,000 feet you go up in the air. And teaching point 4 is properties of the atmosphere. So the properties of the atmosphere allow for various different weather conditions. There are three, and the first one is mobility. This property is the ability for air to move around and create wind, basically. The next one is capacity for expansion, and it is the most important of the three because as the air rises, the pressure decreases and the air expands and cools. When the air expands and cools, it allows for the water vapor inside the air to start condensating and create clouds. And the formation of clouds creates weather, which is and could start to rain. The last property is expansion, so it volume storms. So there are three factors that affect the properties of the atmosphere. There's the temperature, density, and pressure. So as the temperature goes up or down, the density of the air will also change. This creates the vertical movement of air. So if it goes up or down, this causes the expansion as it goes up and compression as it goes down. The vertical movement makes pressure differences, which causes the mobility of air across the surface of the Earth because the high pressure air wants to go towards the lower pressure air. And yes, because it does this because it moves horizontally to fill the gaps left by air that is moved vertically, so moved up. So as air moves up, there's air that comes down to fill the gap that was left. And now we have the confirmation. So can anyone name the three properties of the atmosphere? Yep, mobility is one. That is one of the factors that affects the properties, but is not one of the properties. That's density. And capacity for expansion is one of them. And capacity for compression is also the last one. So there's mobility, capacity for expansion, and capacity for compression. Like Corporal Bailey, the density is one of the factors that affects these properties. And out of the three, which one is the most important? That's correct. Capacity for expansion. And does anyone know why it would be the most important? Yes, we have 6 minutes left. So capacity for expansion is the most important out of the three because as the air rises, it expands and cools, which causes the condensation of the water vapor in the air and creates clouds. And lastly, what are the three factors affecting the properties? It's like Corporal Bailey already named one. Yep, temperature and density are both. And pressure is the last one. And that concludes my lesson. That was EOM 336.01, described the properties of the atmosphere, and I am Flight Sergeant Weens, and thank you for participating in the class.